In this training video film module, we will discuss the installation and adjustment of the single section digital axle counter. Axle counter is a signaling equipment for use in Indian Railways to monitor the presence of a train on a specified track section. This track section can be platform lines, main lines of station yard or block section between two stations. Single section digital axle counter works on the principle of counting of axles of the passing train at the limits of the section and indicates the occupancy or clear status of the section to the operating staff. The first generation axle counters were designed with discrete components and later on with integrated circuits. The axle counter were analog type and were suitable for working on copper cables. The latest version of axle counter is designed using microcontroller with embedded software and is capable of working on both copper and optical fiber cables. Now, let us take a look at the evolution of axle counters at CEL. CEL and RDSO have jointly developed a single section digital axle counter or the SSDAC using a microcontroller. The SSDAC system was designed to RDSO specification number RDSO SPN 177-2003 version 1 and International Safety Standard Senelec Safety Integrity Level 4. The latest model has been designed to RDSO specification number RDSO SPN 177-2005 version 2.0 with error display facility in the reset box. The uses of a single section digital axle counter are as follows. The single section axle counter systems are used in lieu of DC or audio frequency track circuits to prove the clearance of a section. Axle counters are being used in lieu of conventional DC track circuits, block working, intermediate block signaling and automatic signaling. The main advantages of single section digital axle counter system over analog axle counters are: the SSDAC uses high frequency axle detectors, that is 21 kHz and 23 kHz for higher noise immunity to traction current. It has track side electronic counting unit that eliminates the need for separate evaluator. It has web mounted type axle detectors for easy installation and maintenance. The system has track clear relay output provided at both ends. The system works on one pair, that is half quad of cable. The system has lower power consumption and it can monitor long sections up to 20 km. The SSDAC is designed and supplied in two different models. Model 1, single section digital axle counter amplitude modulation type model DACF 700A and DACF 710A. Single section digital axle counter phase reversal type model DACF 700AP and 710P. In this training video film module, we will tell you the installation procedure for SSDAC phase reversal type model BACF 700AP 710p. Wherever required, we will also tell you about the SSDAC Amplitude Detection Modulation Type Model DACF 700A and DACF 710A model. One set of SSDAC consists of the outdoor unit and the indoor unit. The outdoor unit consists of axle detectors comprising of one TX housing and one RX housing, trackside electronic counting unit, that is entry unit and exit unit, one number each, vital relay box and surge voltage protection device. The indoor unit consists of the reset box and their supportive equipments. Installation. Now we will discuss the installation of the trackside equipment of single section digital axle counter. Before discussing the steps involved in the installation of the outdoor equipment of the single section digital axle counter, let's take a look at some important points which should be kept in mind for installing the axle detectors. Ensure that the axle detectors are installed after the advanced starter signal post and the home signal post on up and down lines for use as Bpac on double line section. Ensure that the axle detectors are installed after the advanced starter signal post. Of both the stations for use as Bpac on single line section. In main lines, loop lines, yard area, the axle detectors should be fixed just after the starter signal post of each line under monitoring of SSDAC. Ensure that the axle detectors are fixed on the same rail, that is either on left side or right side of the track at both the entry end and the exit end. The axle detectors should not be installed with entry unit on the left rail and exit unit on the right rail of the track at entry and exit of the section. This will result in both units being counted as in count or out count. While selecting the site for axle detectors near high voltage SSPs and feeder stations, ensure that proper care is taken as per railway procedures of installation of quad cables and proper earthing arrangement. Do not install axle detectors on curved tracks or on bends. The following points are applicable for amplitude modulation type model only, DACF 700A and DACF 710A. Ensure that the length of the trolley protection circuit in case of single line 5 rail length and in case of double line 3 rail length is maintained. While fixing of axle detectors in single line, ensure that it is fixed in the center of 5 rail length. Whereas in case of double line, it should be fixed at 33 meters from block joint in the direction of the train movement. In the installation of the SSDAC outdoor equipment, we shall first discuss the installation of axle detectors. An axle detector unit consists of web mounting type transmitter or the TX coils, web mounting type receiver coils or the RX coils, and the rail deflector bracket assembly. Now let's take a look at some precautions which needs to be taken before installing the axle detectors. 1. Ensure that the separation between axle detectors of two SSDAC systems should be at least 2 meters to avoid mutual interference. 2. Ensure that the axle detectors are fixed in the clear spacing of 400 mm between the two sleepers. 3. Ensure that the size of the rail is 90 R or 52 kgs or 60 kgs only. 4. Ensure that the condition of the worn out of rail is well within the limits. For 60 kgs, it should be less than 13 mm. For 52 kgs, it should be less than 8 mm. And for 90 R, it should be less than 5 mm from the top. Number 5. Ensure that the embossing of rail is never covered by axle detectors. Number 6. Ensure that the distance between location boxes and axle detectors is less than 10 meters as TX coil and RX coil cables are provided with 10-meter cables. Seven. Ensure that these TX and RX coil cables are directly taken to the location box without forming any loop. 8. Ensure that these cables are laid in high density polyethylene, that is HDPE pipes of 40 mm in diameter for safety of cables. 9. Ensure that the HDPE pipes are laid at a depth of not less than 1 meter from the bottom of the rail. And lastly, ensure that TX coil and RX coil cables should run separately in different HDPE pipes at a minimum separation of 400 mm. Now let us discuss the installation of axle detectors. Firstly, fix the marking jig from the top of the rail and fix it to the rail with a clamp. Then using the marking jig, make the marking for 3 holes with a punch on the web of rail according to the rail size. Ensure that for the 60 kg and 52 kg rail, marking of 88 mm is to be used, and for 90 R, marking of 86 mm is used as given in the marking jig. Incorrect marking of 60 kg and 52 kg rail in 90 R rail will result in miscounting. Use ratchet or drilling machine for drilling the hole. First, for drilling the hole, use drill bit of size 6 mm or 8 mm. Then use drill bit of 14 mm size for drilling of web as required. Drilling is done manually, but it can also be done using an electric drill machine like this. Verify the position of holes by fixing the marking jig with clamp properly. Now fix the transmitter coil assembly, that is 21 kHz and 23 kHz on the outer side of the rail. Then fix the receiver coil assembly, that is 21 kHz and 23 kHz on the inner side of the rail. To fix the TX coil housing and the RX coil housing on the web of rail, use bolts, nuts and spring washers of M12 into 100 mm. Use 88 Nm torque wrench to tighten the nuts and bolts. Also ensure that the direction of bolts of extreme ends is different from the bolt at the center. Use 3 numbers of check nuts of size M12 to tighten the axle detectors. Make sure to keep hose pipe attached to TX coil and RX coil housing in curve and not to be pressed in ballast. This curve or loop will help in reducing the tension or damage of housing during vibration. Take the TX coil cables marked with 21 kHz and 23 kHz together in one HDPE pipe to the location box. Similarly, take both RX coils marked with 21 kHz and 23 kHz together in separate HDPE pipe to the location box.